Hello everyone. So we move to still on the exercise 3F. So we solving question number 3 out of about 6 questions that are there. So we only solve the 2, and then we solve the B and the D. So, and it comes with his instruction also. The instruction says find the HCF of the following, leave the answer in prime factors, and then use index notation. So let's solve it together, and please take out your textbooks and your jotting notes to follow me. So we have 2 to the power of 2 times, that is the B part. Then we have 3 to the power of 2 times 5. We also have the next, which is also 2 to the power of 3 times 3 to the power of 4 times 5. Then the last one, we have 2 times 3 to the power of 5 times 7 to the power of 2. So we have to find the HCF of each. So how do we find the HCF of? To find this one is easy. From our previous lesson, when we say 2 to the power of 2, we mean 2 times 2. So when we say 2 to the power of 2, we mean 2 times 2 times 2. That means in 3 times. Here is only one single 2. So you will now see clearly that the number of 2 that is common here is just 1 2. And 2 is here, 3 2's is here, 2 2's is here. So the 2 that is common to all of these 3 expressions is only one single 2. So we put 2 here, meaning 2 is common then. Then we say times, we now move to this. This is 3 to the power of 2, 3 to the power of 4, 3 to the power of 5. So from there, this is 3 to the power of 2, meaning 3 times 3. This is 3 times 3 times 3 times 3, 4 times. This is 3 times 3 times 3 times 3 times 3 times 3, 5 times. So from what we have said here, you will also see that what is common to all of them is 2 3's. We have 2 3. 3 to the power of 2 is common. 3 to the power of 2 is inside 3 to the power of 4. If you remove 3 to the power of 2 from 3 to the power of 4, you will still have 3 to the power of 2 left here. If you remove 3 to the power of 2 from this, you will still have 3 to the power of 3. So that is why you will now write that the one that is common to all is 3 to the power of 2. The same thing here. Here, 5 is here, 5 is there, but no 5 there. So 5 is not common. This is 7 to the power of 2. Here is 7, no 7 in the other one. So we say we have come to the final answer. And we have to leave our answer in a prime factor. These are prime factors. 2 and 3 are prime factors of all these expressions. And then index notation, it has now been in index notation. That is our final answer. It's just simple as that. The D part of the question says 2 to the power of 3 times 3 to the power of 3 times 5 to the power of 3. Then we have 2 to the power of 4 times 3 times 5 to the power of 2 times 7. Then 2 to the power of 5 times 3 to the power of 2 times 5 times 7 to the power of 2. The HCF also, the way we have solved this part, the same way. Here, the common 2's here, we have the common 2's here is other than 2 to the power of 3. 3 2's. We have 3 2's. Multiple of 3 2's is common here. If you remove 3 2's from here, you have a single 2 remaining. Then you have a double 2 remaining. 2 2's remaining here. So it's 2 to the power of 3. The same way here, what is common to all is a single 3. Then the same way here, what is common here is a single 5. But 7 is not common to all the 3 expressions. So we say here is our final answer. And that is just it. Leave your answer in prime factors and then in index form. So we have done that. So thank you for watching, and then we will then move to the number 4, which is said to be the last part of it under factors. Thank you for watching.